Section 9.3, naming and writing formulas for molecular compounds. Here's our objectives. We want to be able to know how to write names and formulas for binary molecular compounds. Alright, so let's talk about naming binary molecular. First of all, when we're talking about molecular compounds, remember we're talking about nonmetals. Two nonmetals bonded together. That's going to be what we're going to see when we have a binary molecular. Binary meaning two nonmetals. That's the key, is what you're looking for. The thing about molecular compounds that's different than ionic is that you can have multiple formulas. So for instance, you can have H2O, that's a particular combination of hydrogen and oxygen. You could have H2O2, that's a different combination of hydrogen and oxygen. So there can be multiple formulas for those, which is why they have to be named slightly differently. So what we do in binary moleculars, we use prefixes. So we have the prefix to indicate the number of each element that we have in the binary compound. Alright, so first of all, once you've confirmed that it is a molecular compound, here's what you do. First, name the elements in the order that they are listed. So whatever order they're listed in the formula, that's the order that we name them in. And then use prefixes to indicate how many of each atom you have. Prefixes that you're going to use, for 1 is going to be mono, 2 di, for 3 it's tri, 4 is tetra, and then after that it's kind of normal math terms, penta, hexa, and so on. So once again, mono, di, tri, tetra, penta, and so on. So be familiar with those. Make sure you understand what those terms mean. If the first one is only 1, then we don't put mono in on that one. We don't write in mono if the first one has only 1. If the second one has 1, then we put it in. And then, just like everything else, we're going to change the suffix of the second one to end in IDE. Alright, so let's do a couple. Let's say we have NCl3. So, we look at it. The first thing we do is we figure out what first of all, I guess we figure out, is it molecular? And the first term is nitrogen. Yep. Since it's not a metal, then we're looking at a molecular compound, so we're going to name it following those rules. So we're going to call it nitrogen. And since there's only 1, we're not going to put the mono in for this because it's the first one. And then there's 3 chlorine, so we're going to call it tri. And instead of calling it chlorine, we'd call it chloride. So nitrogen trichloride. BCl3, same thing. We got boron, it's 1, so we don't need a prefix. Boron trichloride. Ni3, nitrogen triiodide. I shouldn't have 2 I's in a row. I can't get that. Triiodide. Okay. Sorry, can't spell. Alright, so here's one that's a little bit different now. So we have N2H4. So this one we're going to use a prefix. So the prefix for 2 is di. So we're going to say dinitrogen. Dinitrogen. And then our prefix for 4 is tetra. And then we're going to change the last part to end in IDE, so hydrogen becomes hydride. Hydride. And this one becomes dinitrogen trioxide. Okay, so basically prefixes, then the name for the first part, prefix, the name changed to IDE for the second part. Alright, so here we have carbon disulfide. Okay. Alright, so if we want to write formulas for binary molecular, I think this is a lot easier. It's very simple. Use the prefixes in the name to just tell you how many of each one you have, and then just write it down. So they're going to give you the prefixes. You just put down how many of those are when you write them. So if they say phosphorus pentachloride, since there's nothing, no prefix, that means there's one. So it's going to be a P. Penta tells me there's 5, so there's going to be 5 Cls. So really, once you see the name, when you see prefixes in the name like that, you should know that it's going to be molecular. And then you just name it following those prefixes. Okay, so here's one, iodine heptafluoride. Since there's no prefix for the first one, it's just going to be I. Hepta means 7, so it's going to be F7. Chlorine trifluoride, once again, no prefix, so it must just be 1, so it's Cl. And trifluoride means there's going to be 3 fluorines. And just put them in the same order that they're listed in. Just keep going with that. Iodine dioxide, iO2. Okay. Carbon tetrabromide. So carbon is C. Tetra means there's 4, so we're going to have 4 BRs. So CBr4. Diphosphorus trioxide. So now we have a prefix. So we see that prefix. That tells me there's going to be 2 phosphorus. So it's going to be P2. Trioxide means it's going to be O3. Okay, section 9.4, naming and writing formulas for acids. Alright, so let's talk about how we name acids. And first of all, the thing that you need to look for, the key, is this hydrogen. When we talk about an acid, it gives off one or more hydrogen ions. That's one of the ways that we know something is an acid. And so typically, what we see is a formula that's hydrogen, H something, and then something after it. That something after it could be an element. You know, this could be a single atom, or it could be a polyatomic ion. So you could have something like HCl, a single atom, or you could have something like H2SO4, where it's a polyatomic ion. But in general, it's this kind of idea, HX. Alright, so here's our rules for naming. And the first thing is when the name of the anion ends in IDE. And think about this. What this is saying, remember, when things ended in IDE, they were binary. So we're talking about a binary compound. So we're saying, hey, if we have something like HCl, 2 elements, binary, what we're saying is anytime that you see that, you're going to write the name of the acid, you're going to call it hydro. So the word hydro kind of is a word that means binary. Okay, so hydro something, whatever the name of that, whatever that main part of it, in this case it would be the chlorine, and then it's going to end in ic and then acid. So this would be hydrochloric. So I don't need 2 I's in there. Acid. Okay. So there we just did that one. If we have H2S, once again it's binary. Anytime it's binary, you're going to have hydro. So it is hydro. And then look at this part. It's sulfur, so we got to get that in there. Sulfuric acid. So it's hydro something ic. So binaries start with hydro, have ic in them, and so on. If the name of the anion ends in "ite." In other words, this is a polyatomic ion that ends in "ite." Then it becomes us. So ites become us. So if we take a look at this, if you look up SO3, that is sulfite. You would find that on your chart. So if you don't know it, look it up on the chart. Find it, sulfite. Well, ites become us. So this is going to become sul, and then we're going to put this back in here, sulfurous acid. Okay, sulfurous acid. So we looked it up. It was an ite. Ites become us. Take that off, make it us, sulfurous. We kind of add the back in there because it just doesn't sound good otherwise. So they put it back in. Sulfurous acid. If it ends in ate, then it becomes ick. And one of the things that I always tell everybody is just remember, if you ate acid, that's really icky. So we don't want to do that. So ate is ick. So anything that ends in ate becomes something ick acid. So if we have this, we take a look at NO3, we find out, oh, that's nitrate. So it ends in ate. Ate becomes ick. So this becomes nitric acid. Okay? Alright, so now what if we had to write formulas? Well, we just reverse those rules to write the formulas. If you have hydrobromic acid, think about this. Hydro, I said, indicated that it's binary. So when you see something that's hydro, you know it's binary. So now we're looking at something with H, something with bromine, H and Br. Now you really should kind of double check. H is plus, Br is minus. So it's 1 to 1 because they won't always be 1 to 1. But in this case it is. And so that's HBr for hydrobromic acid. Alright, so if we have phosphorus, remember we said ite becomes us, so therefore us becomes ite. So we're looking for phosphite. Okay. So what we're going to do is we're going to look up phosphite, and we're going to see that's PO3. What is that? 2 minus. And then we're going to put hydrogens with it. Well, hydrogen is plus 1. So we've got to do a little crisscross work here. We get H2PO3. Phosphorus acid. Okay, so our next one is formic. So we're looking for formate on the chart, which I believe is C2H3O2 minus. And we have H plus. So it looks like they'd go together, and you just get HC2H3O2. Alright, bases, there's nothing different for bases. Now a base gives us hydroxide ions, but we're not going to name a base any differently than we did when we were doing polyatomic ions, because it's simply a polyatomic ion. So we're just going to follow those same rules. So a typical example of a base is something that contains hydroxide, like sodium hydroxide, NaOH. So we're just going to do the name the same way we did before, and going from the name to the formula, same as what we had before. Alright, so there you have it.